Welcome back. This is part two of the building assessment section site visit module for the quality control inspector lesson. I am Adrian Correa. I'm with Pulaski Technical College in North Little Rock. So we left off taking a look at some photos here and deciding whether or not we have a problem as an inspector or as a monitor out in the field taking a look at work that's been performed. So let's continue with that. We're looking on the left photo. We have a piece of hardboard foamed into place as drywall as a drywall repair, and it's rather messy and it's borderline acceptable. Now, the other issue that we run into is a code issue with this foam. This foam is exposed to the interior, and it cannot be, according to most codes. It violates fire code. It creates a fire hazard. In fact, it would have to be covered with something that is called an ignition barrier to prevent it igniting. We also have an unused dryer vent. This dryer vent, I'm told, has been taken out of service, so that should be sealed up somehow. We have a big hole in the air barrier, so even if we put something temporary in it, such as we cut foam to fit in there very, very tightly, we would need to do something to put our air and thermal barrier back into alignment, back into place, even temporarily. Okay. On the right-hand side, we have sheetrock that looks like it's finished to a level 1, and it's in pretty good shape. They've done a very good job here. I know that it doesn't look pretty, but once it is painted out, it's going to look just fine. We're trying to understand whether or not the work that we see meets minimum standards. And the work on the right clearly does, the work on the left clearly doesn't. So we would accept what is on the right as saying it was performed and it meets standards. The stuff on the left, we would say that it was performed, however, it does not meet standards. Okay? All right. When we're looking at roofs or porches that are attached, or porch roofs, how about that? When you're looking at a porch roof, you have to understand that the way that the porch roof was built generally does not include some kind of sheathing behind it. Normally the framing for the porch roof, let me see if I can draw you a little something here. If this is a stud and we're looking at the wall from the side, in other words, we're looking down this wall from this side right here, or really from the other side, then the framing for this porch was attached to the studs, and it was done in this manner, approximating that. So sheathing was put up here in order to put cladding on, or the clapboards, and the same thing down here in order to put the clapboards on, but there is none here in the center. So we have an open area where air is free to move in and out of this porch and up and down these walls. We also have a lot of glass on the front of this building, which means that folks are going to be pointing at that glass and saying that the windows are the problem. The windows, replace my windows because that wall's always cold, when the real culprit is probably the porch roof itself and the interface to the exterior wall. The answer might be to access this from the outside with a scuttle hole and then install an air barrier that seals off that exterior wall from this porch roof so that we're no longer sharing air from our walls into that porch roof. And we would check that to see if we're communicating with a blower door. We would install a blower door to pressurize the house and then check this porch cavity. So if I have my little manometer over here, let's say it's a DG700, so I've got my little display up here and I've got my input here and my reference here. If I'm outside and I put my reference up into this porch roof, I should see 0. Okay? I want to see 0. If I'm inside and I stick my reference up in there, okay, then what I want to see instead is 50 or whatever I have on my blower door. Is that right? Yes. I want to see a difference completely matching the blower door. That tells me that I have a really good air barrier in place between the inside and the outside of this house, and the porch is an intermediate zone outside of my air barrier, or what I assume to be outside my air barrier. That's the way I would quickly check that. Okay. Another option is to dense pack this porch. If we can't get in there to repair the air barrier effectively, or if it costs too much, we may come in and just dense pack the entire porch roof in order to set up a good air barrier there. Okay. Here we have a tuck under garage, and the issue with tuck under garages is that they share walls and floors with the rest of the house. That means that we probably have bad air sealing, areas of bad air sealing on them. So we want to make sure that, first of all, the roof of that garage, or the ceiling of that garage, is insulated, because that red line there represents where our thermal barrier and air barrier should be. So we want to make sure those are in good shape. We want to make sure that insulation was installed in there. And remember that air leakage between a garage and the home can bring in a lot of pollutants, especially if there's a car that's parked in that garage. When that vehicle is started, it's going to produce very, very high amounts of carbon monoxide. And if that garage is being depressurized by something in the house, an attic fan, a range hood fan, a bathroom fan, then that air from the garage is going to move into the house. We do not want that. We don't want to share that air at all, because it creates indoor air quality problems. Here we're looking at an overhang, and this is a very unprofessional installation of an air barrier, or an attempt at an air barrier, in order to try and give us a good air barrier under this floor, which we do need. We do need a good air barrier on this floor, and then probably insulated as well. They've used bubble wrap and foam in it, and it is just turned into a mess. Now, this can probably be cleaned up, but it's going to have to dry first. But this is not acceptable. Okay. Don't forget to look above drop ceilings. You're going to find all kinds of hidden things. That's usually the reason the ceiling was put there, is because the older ceiling is in really bad shape. Here in this photograph, we're seeing an untreated air leak, as well as knob and tube wiring that is in the wall itself. This is why DOE says that if you're going to encapsulate knob and tube wiring, then it has to be visually inspected, although most of this knob and tube in the wall could not be visually inspected. But it also has to be tested for no more than a 10% voltage drop for the entire circuit. That would include testing this portion that's in the wall to be sure that we don't have a defect in that wall, a defect in the wiring. The other issue that we're running into here is that it appears that we have an uncovered junction of wiring. We've got 3 cables coming together, and the ends just look like they're twisted all together. That does not meet code. Okay, in the house, you want to look for plumbing access panels, or where sheetrock has been broken out. Typically that's going to be under a lavatory or a kitchen sink, and we're to get in there and make a repair to a water pipe or a drain pipe. This appears to be the back of a bathtub. Right here we have the tub valve. Okay, back in here, that is the pipe going up for the shower head. Right back in here, that's the pipe going down for the spout. Looks like we've had a lot of damage back in here, but that is a big hole in the air barrier. If you remember from some of our previous sections, we were showing you pictures taken from underneath the floor of the tub area, and you can have huge holes underneath that tub. So imagine the amount of air that can come through here. We have a very large opening there for a big air leak. If that's coming from, well, the basement, may not, I mean, if it's been pushed outside of the living environment, outside of the heated environment, the indoor air quality in the basement may be pretty bad because it may be a wet basement. Here in Arkansas, it typically would probably be on a crawl space, and you just don't want to breathe what's down there in that crawl space all the time. You can have off-gassing from chemicals, from termiticides, and from other chemicals that have been used to treat, maybe for varmints. You may have waste down there, you know, scat from varmints, urine from animals, and a lot of moisture. Here in Arkansas, moisture is our biggest enemy of comfort. So we want to try and keep that moisture out of the house. This kind of hole would make our air conditioning system work much harder. We'd probably roll or to turn the thermostat down in an effort to get the humidity out of the air, because we wouldn't feel comfortable, when in reality the air temperature is where it should be, somewhere around, anywhere between maybe 75 and 78, or even as high as 82. We can be perfectly comfortable if our humidity is low enough. This is going to allow a lot of warm, moist air to come into the house, or for our conditioned air to leave. Okay, so be sure and look in utility rooms, behind water heaters, in water heater closets, in closets behind bathtubs and showers, underneath all of your sinks. Okay, a drop soffit is an area, and here's a photograph of one that is above a kitchen cabinet. Okay, so this area is the drop soffit, and here's some cabinetry where they've either brought the ceiling down or bumped the wall out, however you want to think about it, to meet the existing, or to meet the top of the cabinetry. Another good area to look in this picture right here, we have a pie plate that is probably covering a hole. We need to look for clearance to combustibles around that vent. It looks to be type B vent, but we want to be sure. But whatever it is, we need to have clearance to combustibles, and it also needs to be air sealed. But here in the larger picture, we're showing how this drop soffit was treated. It looks like they put foam board down and then shot it in with either 2-part foam, that's what it looks like to me, or a 1-part spray foam as opposed to a gun foam. And this cavity needs to be sealed before you insulate, because we need to align that air barrier with the thermal barrier again. And what the folks are doing here in the picture is they are testing the air barrier within that. They've penetrated what should now, or should no longer be, the air barrier, and it should test exactly the way the rest of the inside of the house you would expect it to test, which would be, if you're running your blower door at 50, then you would see a difference of 50 pascal or 0 pascal if the air barrier was good, and something between 0 and 50 if the air barrier was bad. Okay. All right, so inside the conditioned space, we're now inside the house. What are we looking for? We want to check wall insulation. We want to be sure that the auditor has properly modeled the house. So taking a couple of samples in various spots, looking for wall insulation. We want to look at windows and doors. Have they been treated properly, or are they missed opportunities? And then with the blower door running, we want to check for leakage around outlets and fixtures. That'll tell us if our top plates in the attic have been sealed properly, and if we have any more opportunities under the house to do some air sealing, or from the basement. You want to check thermostats and smoke detectors and CO alarms, and make sure that they have been changed out or upgraded or in good condition, as noted on the work order. You want to check around the fireplace and make sure that it is in good condition, that you have clearance to combustibles, etc. You want to look at your air registers. Are they open? Are they uncovered? Are they exposed? We see that quite a bit. We go into a home and we have a client that is covering an air register either with a piece of furniture or a rug, and they don't realize that that causes comfort issues. In fact, they may have covered it because of a comfort issue. They were getting too much air on them because maybe the register was put on pointing the wrong way, or could have been turned around to solve their problem. If we have window AC units, are they sealed up as well as they can be? Recessed lighting fixtures, pardon me, are they air sealed? Are we having leakage around them? We can very quickly check that with smoke running a blower door during a pressurization test, when we actually pressurize the inside of the house. And then how about stored chemicals? Do we have chemicals that are being stored inside the house that are either uncovered or in a place where maybe they shouldn't be, too close to the HVAC equipment or other flammable or other open flame equipment? So we need to check for all of that. On the heating system, if we have new heating coming in, we need to make sure that what was paid for was installed and that it looks correct. Okay. Same thing with a new mobile home furnace. When a mobile home furnace is changed out, there's a pan down here at the bottom that the manufacturer will specify or supply, and that is your plenum connection. That should be replaced. and then also the concentric vent at the top, that should be replaced, or the old one should meet the specifications that the manufacturer of the replacement furnace calls for. The other thing is that this furnace, somewhere on it, somewhere, should have, since it's a combustion product, should say that it is built for mobile home use. If it is not for mobile home use, it won't say it on there, okay? So make sure that the unit was installed, that it's the correct unit. If you don't see for mobile home use on it, or you see a sticker that says, not for mobile home use on it, there's a problem. The other thing you want to do is check with the occupants. Make sure that if you're coming along later on in the process, the furnace has already been installed and it's in service, you want to make sure that their comfort level is where they expect it, that things are working the way that they're supposed to. Okay. Do we have any kind of cracks or leaks on the new components? Do we have any problems? Okay. Excuse me, I think I swallowed a bug. It's too bad. I wish I got to chew it beforehand. Okay. So on air conditioning systems, we want to move restrictions to airflow. Airflow is what makes an air conditioner work, both inside and outside. If you don't have good airflow around it, it's not going to perform properly. That means the outdoor condenser coils should be clean. The indoor condenser coils should be clean. The filters should be clean. The cooling lines, or the coolant lines, refrigerant lines, should be well insulated. In this photograph, we've got an old unit that is not sitting on a proper pad. It should have been installed on a proper leveled pad, and it's pitching the wrong way. Well, it's not even, it shouldn't be pitching, it should be level. There may be liquid refrigerant that's trying to get up into that compressor and may damage it, or it may not be oiling properly, which is going to shorten the life. The coolant level should be checked, or the coolant level, the refrigerant level should be checked and adjusted as necessary under the proper conditions, either through supercooling or superheat, depending on whether it's a heat pump or not. But you should have somebody that's qualified and licensed to do that. If the unit has been replaced, is there a proper manual J that has been run on it? Do we know it's the proper size given what the house is modeling like? In other words, we walked in and we found maybe a 5-ton unit in a 2,000 square foot home. And while most of the time an HVAC technician will tell you, hey, that's pretty average, when we're done with that house, it may only need 3 tons of cooling. So did we put another 5-ton unit in there? Or have we got a unit that's going to be turning off and shutting, or turning on and shutting off very quickly as it adjusts air temperature, because it does have so much capacity to do that, and not running long enough to dehumidify and pull the humidity out of the air so that the occupants will be comfortable? That would be the point of putting in a properly sized system, is so that it runs the proper length of time to both bring the air temperature down and to dehumidify that air and make it comfortable. And manual J is your accepted standard for doing a heat load. Okay. The other thing that you want to do is check with the occupants, find out how comfortable they are with that new unit. If a heating system tune-up has been called for, we want to look to see that the safety of the unit has been assessed. Okay, fuel leaks, clearance to combustibles, proper vent connections, etc. We want to make sure that combustion efficiency has been measured. Do we have the right amount of fuel going in to the unit? Do we need an orifice upsize or downsize? In other words, was the unit installed properly from the very beginning? Do we have a gas pressure issue if it is gas supplied? Have carbon monoxide levels been tested? And those can be affected by a number of things, but primarily dirt and funk and bad gas pressure will cause you those issues. Is it drafting properly under all circumstances? Have we run a worst case combustion safety test on the unit? So do we know whether it's drafting properly? And then has the heat exchanger been inspected, as well as all the safety devices like temperature limit switches, etc.? Have all of those been tested to be sure that what we're doing is correct? And then we get into unvented space heaters. inside. As we find these, we need to understand that DOE does not allow air sealing measures where permanently mounted unvented space heaters exist. So if we have a space heater that is not freestanding and mobile, we can't do any air sealing. Okay, and the other thing is we have rules about, and they're very, very limited, about when a space heater may remain and the house receive weatherization at all. In other words, they have to be a secondary heat source only. They have to be of a certain size and smaller, etc., etc. So if you look at program notice WPN 11-6, that gives you quite a bit of it. It's going to refer to an earlier one as well. And that will give you even more information on these space heaters. Okay. Open returns. What we have here is a draft hood. This is the draft hood right here on the side of a furnace. This is an older furnace. It's probably a 60 or 70% efficiency. We have the vent for it coming up here. This is the vent pipe for it. Okay. The draft hood itself is not very well connected to the furnace. And then over here we have a return. This is a downflow furnace, meaning air goes down through it. So we have an open return, and that's depressurizing this area, and you can see right here where we are pulling or leaking exhaust gases from the draft hood. So this is not a good clean installation. This is a dangerous installation, and this needs to be corrected. So we don't want these gases inside the house at all, even if we have low CO. We may not have low CO under all conditions, and certainly as the unit works, it's going to get dirtier, it's going to become less efficient, and an inefficient burn means that CO production goes up. So on the venting system, what we're looking for is for one that carries all the exhaust or the combustion byproducts to the outside. It should draft very quickly. It should not take a long time to establish a draft. It should be sized properly. And the National Fuel Gas Code is the accepted standard for doing sizing on vents. Okay, it tells you how many BTU, how many horizontal feet, how many vertical feet, what size, etc. It should also be built out of a very durable material. You don't want to see black steel, single wall vent pipe on an 80% furnace. It's probably going to rot out pretty soon. You'd rather see double wall B vent, which has an aluminum interior and a galvanized steel exterior, and two, a concentric. It's not truly concentric, but two pieces of pipe that have an insulated, air insulated space in them. And we also want clearance to combustibles and no overheating of surrounding materials. Don't forget, radiant energy is a big issue. That's one of the reasons that double wall vent is double wall, to prevent that radiated energy off of a single wall from overheating things and causing problems. The other thing is a vent should have, now this is saying makeup air, but another word for that, or another term for that, is dilution air. The vent needs proper dilution air in order to dilute the combustion byproducts and bring the dew point way down in that flue gas, so that we don't have condensation. We don't have condensing taking place in that flue. So here on the left-hand side, we've got a flue exit from the boiler, and you can see it is moving almost horizontally, almost perfectly horizontal. Okay, that should rise at no less than 1/4 inch per foot. Now, when we get to the other side of it and look at it from the other direction, we can see that is a very long horizontal run. This is trying to get over into this big masonry chimney that we see in the photo on the top right. But if you look carefully at the wall where that interface of the pipe and the chimney is, you see that we've got rust. That's evidence of condensation. We also have a hole that's rusted out in the bottom of the unit. So this unit is not performing properly. It's not drafting properly. If you come back and look at the unit just off of the boiler, you're going to see a lot of rust stains on the vent itself, which tells me that it has been condensing in that flue pipe quite a bit. So this is not a good installation at all. Those flue gases are the single wall pipe, which is what it appears the vent is made out of, is way too close to the dew point of the gas, the exhaust gas in there, and we're getting a lot of condensation as a result. Okay, This one I like to call Honey, I Fixed the Furnace, because this really looks like somebody spent a lot of money on fittings and did a very pretty job, but not a mechanically good job. If the flue doesn't make mechanical sense to you when you look at it, if it doesn't seem like it's going to flow very easily, then it's probably not. We've got a lot of elbows. We've got big changes of direction here, and we have a flue coming in at a right angle from the water tank. So what's wrong with this picture? Well, let's just make this easier. What's right with this picture? There's very little right. We just have a lot of stuff going on here. A lot of flow, a lot of restrictions. So bad thing, bad thing. Clearance to combustibles. Here on the left we can see that we may not have enough clearance to combustibles right and left of this this pipe. Now this is probably an oil burner, and the reason I say that is because here is the single vent, and then we have a radiant shield that's going around it, going to the outside. We're pulling air from someplace else. We're not pulling it from up top. This is in a mobile home. This is a mobile home roof jack, and here they have come back and done a pretty good job of air sealing and getting clearance to combustibles. But you can see right here, and even in the front of this flue, we may not have proper clearance to combustibles. And NFPA has combustion clearance tables available for just about any type of fuel burning appliance ever made. Okay, filter replacement. The filter should be in good shape. There should be client education that is taking place. In a lot of cases, this is going to be the quality control inspector as well as maybe the auditor that's doing this, showing them where it is, showing them how to change it, showing them what type of filter they should be purchasing to put in there, and showing them the flow direction on the unit and giving them a schedule of how often to change that filter. Okay, and then we've got duct sealing. It's important to seal ducts that run to the outside of the house, because you're going to be losing conditioned air under pressure. So you're not only just have an air leak, but you have an air leak under pressure, which means it's going to move a lot more air. Probably one of the better materials to use is duct mastic. Mastic and mesh tape is fairly inexpensive. It's specified and preferred in most field guides that I've found. A two-part spray foam can be used to seal and insulate ducts. However, remember, the inside of the duct is still considered an interior space, so you cannot have the foam in contact with the inside. You've still got to put some kind of block over that to prevent that. So that probably means butyl tape and then spray foam over the top, or at least an aluminum tape and then spray foam over the top. Okay. Here we have a duct, and this appears to be a panned return or a pan duct, where we're using the structure of the house. In this case, we have a floor joist, okay, possibly down in the basement, and they've put sheet metal across, 2 of them, and then they've come back and air sealed each of the joints in order to make this as tight as possible. They are using this floor joist as a path for air to move in. And my question is this acceptable? Is this okay? Is this an all right thing to do? Modern codes have gotten away from this. They no longer allow it. However, codes when this house was built probably did allow this. So is it acceptable? Yes, but it should be very well air sealed, because we don't want to pull air from an unconditioned basement or crawl space into our HVAC system in order to just raise the temperature or lower the temperature on it, because it's so much different from the return air coming out of the living space, coming out of the living room. Now here they've used caulk in some places. I think duct mastic probably would have been a better choice. The best practice here would have been to have built a duct that would fit between these floor joists instead, a proper duct. But for money wise, you can't always do that. Okay, you don't always have enough money, you don't always have enough labor dollars to be able to do that. In mobile homes, boy, mobile home duct work, I've never heard anybody say anything good about mobile home duct work except when they come across that one in their career that just doesn't seem to leak the way they expected it to leak. So they're always going, wow, these guys did a much better job than I thought they were, that I had a right to expect. Folks, I'm going to stop here for a minute. I know we're only about 30 minutes into this, but I think I need to put batteries in my microphone, so I'll be back here in just a minute.